We're still waiting for a couple of people connected. We are very blessed with this webinar. People from actually all over the world have connected for this webinar. I was quite surprised. Yeah. I think we have people coming. If I'm just looking at the quick map over there, we've had people registering from Angola, from Zambia, from Namibia, Botswana. We've had people as far as Nigeria. We have people from Ghana, Ivory Coast, and if I remember correctly, also some from Middle East.
Middle East, Australia, New Zealand, some from the US.
Yeah, US as well.
US as well.
Excellent. So now this webinar is really bringing people together from all over, and it's all to do about the FLIR Si124. I think we're going to give it a minute or two just for a couple of more people to connect. They might have some connection problems. But yes, in the meantime, we're just going to wait a little bit. I think while we're waiting for them, I'm going to start off with a couple of big thank yous. A very big thank you for Adhir for assisting Yellotec in organizing this webinar. I think it's a long time coming, something we've been planning for quite a while. I'm very happy and it happened.
It's been quite a long time that we've been planning, but yeah, I'm glad it's finally here and we're going ahead.
Excellent. And then also from the Yellotec office, Magda Weideman, she's really put in a lot of work here. She's even assisting behind the PC here. Thank you very much, Magda, as well. Good. And then also connected on this webinar is our marketing team, Jade and Esther. I'm very happy for them to connect as well. There's been a lot of work coming from our marketing team to make sure that everybody knows about the webinar, knows what it is about, informing people about us, the speakers, the agenda. Thank you very much to Jade and to Hester as well for it. Okay. While we are waiting, we're going to start off very soon. I don't want it to go too long. There's a lot of information to share. But yeah, guys, please keep in mind this webinar is being recorded. It will be available for download afterwards as well. We will send out a thank you email to everybody with a link to download the webinar. The presentation will also be available in PDF format, and we will also set available some data sheets about the FLIR Si124, as well as a brochure as well. But yes, at any time, you will see the Q&A is open for questions. We will leave the questions until the last slide. Yes, otherwise it might be dragged on just too long. So yes, don't be scared to place your questions beforehand, but we will answer all of them at the end of the day. Okay. Good. I think we can actually continue. Like I've mentioned, it is being recorded. So if anybody's having trouble to connect and want to watch later, it will be available. Good. Excellent. Thank you, everybody, for connecting to the Yellotec webinar in assistance from Teledyne FLIR as well. And as I've mentioned, this webinar is all about the acoustic camera, the Teledyne FLIR Acoustic Imaging Camera, or better known as the FLIR Si124. We're going to have a quick discussion on what is acoustic, what is ultrasound, why an imaging camera is important. Adhir is actually going to show us a little bit more about that. That's going to be a small, quick discussion. I want to go directly then into the air leak, on how to detect air leaks using an acoustic imaging camera. After that, Adhir will then be focusing around partial discharge, corona, which is also possible with the FLIR Si124. Good. But before we continue, a quick introduction from myself. My name is Reynhard. People just call me Ray for short. Yes, I've since 1997, when I first picked up a thermal imaging camera, fell in love with predictive engineering or reliability solutions. Ever since, been busy with preventative and predictive maintenance. And yeah, more recently joined Yellotec, now almost my third year with Yellotec, and still going strong. And then joining me today as well, friend, colleague, sales manager from Teledyne FLIR for
Teledyne FLIR.
Sub-Saharan
So my name
Africa.
is Adhir Ramborosa. I am the sales manager for Teledyne FLIR. I find it ironic how Reynhard started his hand down, where Chart has actually introduced him to the first thermal imaging camera. And Reynhard was the first person to put a FLIR thermal imaging camera in my hand. And we've been friends ever since.
That's it.
Yeah, we together presenting today now.
Good. And yes, we're always talking about thermal imaging cameras. And I think that's also what Teledyne FLIR is the most famous for thermal imaging cameras. But now we are actually evolving into more technologies. Instead of seeing thermal or temperatures, now we are actually seeing sound. What a exciting time it is that we actually live in. But before we get to that, just a quick overview. I'm not going to go too much in depth with it. That's a small little diagram of the history of Yellotec. Started in 2004. Infrared thermography has always played a huge role for Yellotec. From there, we evolved into other core competencies like the vibration, like the lubrication. Training is a big part for Yellotec, laser alignment tools, balancing. So right up to a couple of years ago, when we started to create solutions or turnkey solutions online as well, vibration, thermal online, all of those type of technologies that Yellotec can also offer. Even talking about a longer history, if we look at FLIR, it actually started as AGA back in 1958. That's a couple of years now already. FLIR itself, or FLIR brand that we know today, started in 78. Around about 85 that they've acquired a GIMO range. Yes, and I think the exciting time for me was around about 1997. I was still running around with a GIMO 470, which was a cooled unit. And in 97, it was the first uncooled thermal camera. And we can actually see how it evolved even with the OGI cameras, the optical gas imaging cameras. Thermal within multimeters, that was the start of the lectin core, which also made the FLIR 1 available. And like I've mentioned, now more recently, what this whole webinar is going to be about, the Si124. And then, of course, not to forget, in 2021, when FLIR systems transitioned into Teledyne FLIR that we know today. Good. But I think let's start off with, before we talk about the Si124, let's take it from the beginning and actually start with a quick question about what is acoustic imaging camera? Why do we need it? And I think a question that I might also have is, my wife always says that I do not listen. Does that mean that she's actually talking in the acoustic range? Or
no, Ray, that's actually selective hearing. I think, yeah, most of us married people have got that, be it from the husband or from the wife. Okay, so thank you very much, Ray, for that introduction. So yes, the question, what is an acoustic camera and why? And in order to understand that, we first need to just understand a little bit about ultrasound. I think a lot of people may be familiar with this little spectrum on the infrared spectrum, but this is now on the ultrasound wavelength spectrum, okay? And if you start to look at it, ultrasound is basically sound that is inaudible to the human ear. It's just above that audibility scale, starting from 20 kilohertz, okay? It actually makes it a really good diagnostic tool. I think some people are familiar with it in the medical space, but it's also good in the mechanical and electrical space, okay? So if we start to look at this predictive maintenance curve, you will start to see that the ultrasonic spike is actually one of the first things that can be detected when it comes to predictive maintenance. And because of this, you're able to look at electrical faults, mechanical faults, gas or compressed air leak faults much earlier in the predictive maintenance scale. So why ultrasound? Okay. A pressurized leak will normally create a lot of turbulence. And unfortunately, the only technology that's able to see this is ultrasound. When air leaks into air, it's very difficult to detect other than using ultrasound. Also, when it comes to partial discharge, you can scan a substation or look through a substation 10 times faster than any other technology that's available. You're able to filter out any background noise. And again, you're able to see. So seeing is believing, it's more visual. So here's introducing the Si124. So this unit has got 124 MEMS microphones in it, which makes it a highly sensitive unit. Minimal training required. It's literally a point and shoot type unit. And you're able to detect both PD and air leaks using this unit. So talking about air leaks, Ray, I'll give this back to you.
Excellent. Thank you, sir. Good. Yeah. Detecting compressed air leaks. I would make the comparison of probably saying that had the same effect of thermal on electrical. You just pointed to it, it's a cabinet, and you can actually immediately see if there's what they used to call a hot connection or a faulty connection. And it's very similar than what you are using with this unit over here. Over here, you can see we have 2 units in our hands over here, 124 directional microphones in front. And it's the same as what you use a thermal camera for, basically scanning your air pipelines or your air system, looking for that specific area where you actually see an air leak that is coming from. How does it work? Well, it's very similar than our lungs and our lips. So I think that's an easy comparison. If I just breathe in normally in and out, there's a normal flow of air. We don't hear anything. We probably don't hear anything. Probably some animals might hear it, but for us as human beings, we don't hear it when somebody is just breathing. As soon as I start pressing my lips together and I start to create let's say a compressed chamber within my mouth, like what he is doing now, we actually start to hear that whistle. Funny thing about a whistle, I can do it with wind going out of my mouth, but I can do the same with wind coming into my mouth. So whether it is air escaping from a system or a vacuum pulling air back into a system, it's still that collision of molecules that's creating, or that fast accelerated collision, that turbulence that's creating the ultrasound. And that is what these units are actually designed to pick up. And you've mentioned selective hearing because of Great Husband. And it's almost like selective hearing, I would say, for the Si124 as well, because it narrows into that frequency that it wants to pick up, or that it is specifically for air leaks. So if we're looking at, let's look at what we can actually save. Does air leak cost us money? Well, in the US, the Department of Energy, they are already estimating that 30% of manufacturing facilities' electricity is consumed just for compressed air, which kind of makes sense because we know how many compressors is not only in manufacturing plants or breweries, food and beverage, even oil and gas. So yes, we can easily say for just industrial electricity, at least 30% usage is for compressed air. On an average, a third of compressed air is wasted due to leaks. So for that 30% of electricity that we're spending on making the air, we're immediately losing a third. So if we take a simple example of a 200 horsepower motor, it's around about 150 kilowatt compressor, working 6,800 hours per year at, let's say, 11 US cents per kilowatt hour. That's almost $40,000 that's being wasted.
Yep.
That $40,000 is already buying 2 units, if not 3. Okay. So let's have a look at, again, just a small comparison. If I ever look at specific sizes, a leak size from a 16th inch, a quarter inch, right up to half an inch, and we look at, let's say, a compressor from 5.5 bar, that's around about 80 psi. And if we compare that leak on a 16th inch, let's say 16th inch and quarter inch is very popular within manufacturing plants if we're looking at leaks. That is between $720 to $11,500 wasted or lost in a year from one leak.
Exactly.
Just one leak. So yes, 40% of energy used in factories can be lost due to leaking pneumatics. And how many pneumatics are we using? A typical plant could have a leak rate of 20%. That's not just one leak. That's a whole couple of leaks. So if we look at a whole system, that's just a basic diagram of the system. Where do we look for air leaks? Well, I think the most obvious one is the couplings, tears in hoses, tubing, fittings, pipe joints, quick disconnects, regulators, you name it. There where air is actually going through, you can find a leak over there. Great thing about these units, they are visual. I can visually see where it is coming from. I don't have to go do soap test. I can be from a distance, but I'm getting a little bit ahead of myself.
That's going to save you a lot of time.
Can you imagine? Just the time of waiting for scaffolding to get to the tubing on the top. Can you imagine? Good. This is a nice challenge for anybody that's interested. On this image, there we can actually see the unit over there with that's an argon gas, if I remember.
Correct.
Argon gas feed pipe in there, and that pipe over there is leaking at only 2.2 liters per minute. That's the smallest one we found so far, and I think you still found this one.
I still found this on the plant. It's obviously a robotic welding arm, and nobody believed that there actually was a leak until we proved it out, and it's subsequently been fixed.
Good. That leak only cost about 200 Rand per year, but I still want to make a challenge for anybody. If you find a leak smaller than that, I would definitely like to know
I would
about
also love to, yes.
Just a quick one. You will see on the right-hand side all of the settings over here. Distance 2 meters away. That's from where the guy was standing using the Si124. How many hours is that robot arm moving? How many days is it working in a week? What's the ambient temperature, humidity, the normal? And then what is the actual power of the power consumption of that compressed argon? And then what is the rate that you buy your electricity from? And all of these settings can be programmed into the unit, either into the unit, or you can even adapt it in the software.
As well. That's correct.
You do have a bit more about the software in your presentation.
I do have a bit.
If you do those settings on the camera itself, it will immediately give you the outputs below, the 2.2 liters per minute and 200 Rand per year. If we, for example, look at a more common fault, this was at the automotive factory on one of the line conveyors. Now, the interesting thing over here is I'm not standing right onto the conveyor. You're standing quite a nice distance, a safe distance away. And still we're picking up that something is leaking over there.
And that's in a rather noisy environment.
That's very noisy.
To pick up that little leak.
Only because it focuses on it.
It focuses on the frequency.
That's it. And this is the information on the right that you will get on the camera. I know it's a little bit small, with these screen grabs. It's difficult to bring the resolution while you are making the image better. But right over there, we can see that that small leak on the conveyor is already costing this assembly plant 5,000 Rand a year. Doesn't sound like a lot of money, but if you find 10, 20, 30 such faults, each one 5,000, 6,000 Rand per year, it actually adds up to quite a lot. One of my colleagues was working on I'm just going to say food and beverage plant, and within 15 minutes, I want to say 10, but let's be fair, at 15 minutes, he already found 3 faults, which was bigger than this. All of them roof level, which he has done from the ground level. Here's just a couple of more examples. for each one of these there, you can actually see it's quite straightforward from that it's not on the connection plant. And you walk past these connection points and you're always thinking, it's leaking out where the connector is. But over there, we can actually see that it's the feeding pipe that is leaking, and it was actually eroded through there. Another connector on top over there. Over here, we can actually see from underneath. In other words, we cannot really see the equipment itself, but immediately we can see how the sound is bouncing off the floor, and we can detect that there is an issue coming in from over there. Nice thing about the Si124, you can stand a distance away. You can stay at a safe distance looking at equipment. I think it goes up to 100 meters. Correct. Up to 100 meters away that you are able to pick up the leaking air. This is also a nice image from where you're standing on ground level. Areas where you're not permitted to go into without hot work permits. I remember one of my colleagues were actually standing at the door looking into a factory because we were not allowed without the permits. And we were only there for limited time. But immediately we can actually already see where the leak is coming from. And from there, we can actually now start making plans and say, we want to go look at something very specific over there. Manifolds, air filters, air regulators. The other day on a compressor, we even found that the compressor, the pressure relief valve was not closing properly after the pressure has been relieved, which is a problem because now you have to keep on producing compressed air just to keep the pressure up. Yeah. Manifolds again, pneumatics, ammonia compressors, argon compressors, oxygen. Even oxygen. Hospitals. In hospitals, all of that oxygen lines is coming from a compressor that we need to monitor as well. When we start talking about difference between, will I be able to pick up a gas leak? The best answer for that is only compressed air. No, I wouldn't say air. Let's say compressed gas units. If it's compressed, in other words, it's forced through the small hole, it will make a sound and the unit will pick it up. Remember, it doesn't need to be audible for us. The unit will pick it up. But if it's just free-flowing gas, no, it's not going to work.
Remember, like I mentioned, it has to fall within the acoustic spectrum. So basically from 20 kilohertz. And if it doesn't reach that pressurized zone to be able to create that sound, you're not going to get it.
And that's very important to understand. If it's just a free-flowing gas, it's not going to work. That's it. Good. That was a quick summary about the air leaks. I'm going to hand over to Adhir again for a bit more on partial discharge.
Thank you, Ray. So am I doing the electricity because I'm electrifying or?
You're sizzling.
Thank you. All right, guys, partial discharge. Obviously, the big word in your high voltage spaces. Everybody that runs a high voltage line is really concerned about partial discharge. Okay. The question is, what is partial discharge and why is everybody concerned about it? So partial discharge is defined as the dielectric breakdown of insulation. It's a very simple explanation. But what does it mean? What does it cause? Obviously, breakdown in insulation causes catastrophic failure. All right. If you look at it, partial discharge can actually occur between phase to phase, phase to ground. It can occur in solid insulation, bubbles within a transformer, air bubbles within a transformer, the gas around an electrode. So partial discharge can occur in all of these places. All right. And just some quick examples for those of you that have got substations or worked on high voltage lines. You start to see that these are actually examples or points of where partial discharge can form. Okay, here you've got a termination. It's discharging through the actual insulation. On the far right here, you've got discharge on the actual line. Okay, so why is it bad, Ray? How often have you walked through a substation and heard the buzz?
You talk about high voltage substation?
On a high voltage substation.
Well, I would say most times when you walk in, you hear.
How often do you see it?
No, not that much often.
Okay. So why is it bad? I think Ray's got a little bit of electrical background. He understands. But partial discharge causes, again, it keeps on saying catastrophic failure if it goes undetected. And here is a good example. Partial discharge can cause things like arc flash, fire. This is an electrical treeing effect in solid dielectrics. So it's definitely a fire hazard and can cause major damage to your equipment. All right. But partial discharge has got three different classifications. One being corona, two being tracking, and three being arcing. So judging by sound, are you able to differentiate the difference between the two or the three?
No, I just hear the buzzing sound.
But the SI124 can do this. So the SI124 uses machine learning and AI to actually tell you what type of discharge it is, be it corona, arcing, or tracking. All right. And again, Ray, you made mention of the software. All you've got to do is plug the unit in to your PC, extract the images, and the software does the rest for you. Based on the actual frequency of the sounds or the breakdown, it uses AI to distinguish exactly what type of PD it is and how destructive or not it may be. And it's as simple as three inputs, very similar to how you were doing your LEDs. It's exactly the same. You've got your distance. Distance is always very important. Then you've got your voltage, okay? And thirdly, location. Location meaning component. Is it a corona ring? Is it a transformer? Is it a termination? You just put in those three things and it uses, again, machine learning or AI to tell you exactly what the severity is, a quick description of exactly what is going on, and a recommendation of what could be done to resolve the issue.
The AI gives you the recommendation.
The AI gives you the recommendation. So you do not need to be extensively trained on the unit. It does everything for you. All you need to be able to do is take a good picture.
Okay.
So this was done under controlled circumstances. If you look here, we're simulating a fault. Okay, this was an internal cable fault that we were trying to simulate, or that we did simulate. And as you see, the first thing it tells you severity level is very high. Okay, here's the description. It starts to classify the discharge, and it gives you some form of recommendation. Obviously, immediate action in this case, due to the fact that it's high severity.
Excellent.
Okay, so let's go through some examples of partial discharge. The first thing you'd note is the wide field of view on this camera allows you to scan a complete substation a lot faster with pinpoint accuracy. Okay, if you've got multiple discharge points, you're able to pick up multiple discharge points at the same time. Okay, you can then subsequently pinpoint exactly which one you want to look at and go to that and do a proper survey on that. Okay. Here we've got a faulty line, again, discharging through the insulation. Okay. This is the track that is coming through. And again, the AI tells you exactly what sort of problem this may be. So a bit of a description and a severity. Severity obviously being critically important.
On that image, for example, it mentions from 26,000 hertz to 31,000 hertz. The AI automatically sets it up.
So the AI on the camera actually picks up on that frequency band. So we're able to, again, take out all of the noise and we can pinpoint on that specific frequency band.
And then it breaks it down into the discharge prediction and it gives a recommendation.
It gives out a recommendation. Exactly. Right. Here again, you start to look at some of the other examples in open air substations. You've got insulators that could be faulty. Now, a lot of times when you hear this buzz, it's multi-directional. So again, being able to pinpoint exactly where the frequency is coming from is critically important. And the fact that you can see the sound is also important, because now you're able to pinpoint exactly which location you're going to.
Excellent.
Okay. Again, here we've got some high voltage corona discharge. Now, please bear in mind, not all discharge is disruptive or destructive. Here you can see this is a discharge into air. So that's not particularly dangerous at that point in time. Okay. And here we go again, more examples. You've got insulators, dirty insulators. What happens? It starts to create a surface discharge, and this could be dangerous. I mean, surface discharge can cause a meltdown in the substation, and then you've got areas without power and breakdown again, and the cost of breakdown is obviously really expensive.
And a nice thing about it is all of this is done from ground level.
Exactly, it's all done from distance. Okay, here are some other examples of discharge. Again, insulator. Take note of the severity at the bottom. You know, it tells you how soon you actually need to do the job or to do the repair, which I think helps the criticality point of view. How often have you seen discharge on a connector or contactor? I mean, this could create hotspots, right?
Eventually, yeah.
It could create hotspots. Again, critical breakdown. Another connector fault. And then on your high transmission lines, lots of times if you're walking under your pylons, you hear the buzz, you're not sure where it's coming from or exactly what the situation is. So you can use the Si124 to actually detect exactly where the sound is coming from and what the fault could be. So Ray, I believe you're giving off a nice special regarding this with this unit.
Excellent. Yeah, thanks for the reminder. Because we are very thankful for everybody that's connecting for this webinar, we have decided to put forward a special offer. Please keep in mind that for the Si124, there are three different models, three different basic models. We have the unit that you can only pick up air leaks. In other words, if you buy that unit, the frequency is set only for air leaks. Then on a different unit, it's exactly the same. The frequency is limited to only partial discharge. Software is included with all of them. The AI is included with all of them. But then we also have the unit that you can pick up the air leak detection as well as the partial discharge detection. So yes, on all of those units, any one of those units for attending this webinar, all you need to do is to send an email to info@yellotec.com, or you can request a quotation or demonstration from sales@yellotec.com. But remember, in the subject line, you must put Si124 webinar. As soon as you put Si124 webinar in the subject line, it will allow for additional discount on a unit. Keep in mind, that's a very limited time and very limited T's and C's connected to that offer. So yes, get your request into info@yellotec.com as soon as possible. And do not hesitate to book us for demonstrations. We do have the demonstration units available. If you want to see it in action, I know on TV everything sounds great. Don't want to sound like an infomercial, but wait, there's more. But yes, I would definitely, if you still have questions, if you would still like to see the unit in action, contact us, get us on your site, and let us do a quick demonstration for you. Like I've mentioned at one of the food and beverage companies, we found 3 faults within 15 minutes. So that's how confident of air leaks. I must say it's not faults, it's air leaks that we found within 15 minutes. So yes, now we're very confident in the product. We're very confident in Teledyne FLIR, but we're looking forward to meeting you on site as well. But yes, guys, the info@yellotec.com and sales@yellotec.com. that is direct lines to us. So you're more than, I see a hand raised.
Does the device come with training?
I'll give it to you in a plain and simple answer. This unit does not need certified training. Okay, it's a couple of settings that you do need to change, but you don't need to understand ultrasound. You don't need to understand partial discharge. You don't need to understand turbulence or frequencies. The unit basically does everything for you. It's different from other ultrasound units. I'm going to mention structural bone ultrasound, bearing ultrasound. It's different from that. For that, you do need some training. For that type of ultrasound, you will need certification. But for this unit, it's more of a basic product operating training, for which there is an online training at irtraining.eu available as well. I will share the link on the chat as well. I hope that answered the question. Good. Any other questions?
Okay.
In the meantime, Ray, if I had to elaborate, so like you said, it's a very simple, easy to use instrument. Literally pick up and take a picture. And the software does all of the work for you again. So the AI in the software does 90% of the diagnosis, as well as the recommendation.
Now, basically, all you need to do is say, I want to check for air leaks, or I want to check for partial discharge.
Exactly.
That's the only settings you change, plus what's my distance and kilowatt hour.
Yeah.
Now we have another question.
Yeah.
Good.
Will it be able to detect a vacuum leak covered with insulation?
It depends on the insulation. To pick up a vacuum leak, yes. We've had a couple of tests already done on it. Like I've mentioned before, with the whistle, you whistle out and you whistle starting in. So it's the same type of effect. Remember, the vacuum pulled the air from outside into it. So yes, you can pick up a vacuum leak, but I'm very careful to say about the insulation. I would like to test it on the specific insulation that you require.
Then what are all the frequencies it can detect?
So in this case, it can detect from 20 kilohertz going all the way up to 60 kilohertz. There is an LD unit, a Si124 LD plus unit that goes up to a higher frequency range.
But for air leaks, it's between a specific frequency, and for partial discharge, different one.
Then we have Alan asking about the price.
Send your request to info@Yellotec or sales@Yellotec. Remember the Si124 webinar, and we will send you through a quote immediately.
Does the unit detect the distance, or does the operator need to input?
So with the FLIR LD plus unit, it automatically detects the distance. However, with the other units, you've got to manually put it in. That is still relative. So if you're looking at distance, very often you can judge without being extremely accurate. You can judge exactly what sort of distance you are away. And that can be done. You can put in the distance onto the device itself or onto the software when you're actually using the device.
Good, but I think we've done good timing. Please, especially the guys with the hands up, you're more than welcome to actually still put in the Q&As. I see a couple of popping up, but I don't see the typed out questions. Unfortunately, we cannot do the microphones at this moment because of the webinar settings.
Here's another question. Insulation, does the heat resistant fiber covered with thin 0.6 millimeter metal?
I don't foresee a problem, but it's best to always test it beforehand. Depending on where he is, we can always arrange either for a demonstration or if there's some traveling involved, we can make an arrangement for him.
That's for it.
Good, guys, you're more than welcome to send more questions to info@yellotec.com. Always remember just to start the subject with SI124 webinar, so that we know that it is related to this webinar. But yes, all of your questions are still welcome afterwards. Good. Any other question, Martha? All good?
Can we generate reports from data recording?
Yes, so using the software, and again, the software is free. There are two versions. One is a web-based online version, and the other is FLIR Thermal Studio that can actually do your reporting. And again, all you've got to do is upload the pictures to the web, which the unit actually connects to Wi-Fi, or with the USB that comes with, download it, upload it into your PC, and you can do complete, comprehensive reports.
And that's actually a very important question, isn't it? Because I would have thought on the plant, detect the leak, mark the leak so that we can actually schedule it for repairs, maybe make a note on the tag about how many liters per minute costing, etc.
Yeah.
But a lot of the people is actually offering this as a service as well, from which they have to compile a decent report, a decent looking report. So that's a very important question, yeah.
Let me just see.
I think some of the people might have problem typing.
When and how will the webinar recording and presentation be available?
Within the next 24 hours. We're just basically waiting for it to finalize. Then it needs to process. We need to download it, and then we share it with everybody.
All right.
Excellent. Adhir, really big thank you from my side. I really enjoyed it, and I'm looking forward to the next one.
No, cool. And thank you to all the attendees. I mean, it was brilliant having all of you.
Got a new question.
Let's go back to the question.
Is it possible to pinpoint faults on a MV-MCC panel?
MV-MCC, medium voltage motor control center.
Yes, you can. You can, so long as, but it becomes a question of, is it line of sight or are you able to see it? But remember, if there is any partial discharge within the panel, using the device, you'll still be able to see as the sound is going to escape from some point or the other. So you do have some sort of reference point to say this particular panel does have some sort of discharge.
Good. I think let's cut it over there. We will still have access to the questions after the webinar is closed. But guys, please send your questions through to info@Yellotec. Send your quote request through to sales@yellotec.com. Remember to start the subject SI124 webinar. Good.
But again, thank you to the Yellotec team for having me on this webinar. And thank you to the attendees for joining.
Excellent. Thank you very much.
All right. Cheers.
Thank you very much, everybody. Enjoy the rest of your day.
Bye-bye.